Good morning. I am Victo George, working in Department of CSC, Dr. NGR Educational and Research Institute. Today we are going to talk about the topic Overview of Cryptography and Network Security. To start with, what is actually computer security? It is the protection afforded to an automated information system in order to attain the applicable objectives of preserving the integrity, availability and confidentiality of information system resources. The key security concepts are confidentiality, integrity and availability. What is confidentiality? It is preserving authorized restrictions on information access and disclosure. Integrity, which is guarding against the improper information modification and destruction and includes ensuring information non-repudiation and authenticity. Availability is ensuring timely and reliable access to and use of information. To access effectively the security needs of an organization and to evaluate and choose various security products and policies. The manager responsible for security needs some systematic way of defining the requirements for security and characterizing the approaches to satisfy those requirements. This is difficult enough in a centralized data processing environment. With the use of local and wide area networks, the problems are compounded. The ITU-T recommendation X800 Security Architecture for OSI defines such a systematic approach. The OSI security architecture is useful to managers as a way of organizing the task of providing security. Now, the aspects of security. There are three aspects of information security. First one, security attacks. They are active and passive attacks. Secondly, security mechanism. The examples are encipherment and digital signature. Third one, security services. The examples are access control and authentication. Now, the model for security. And here, if you look into the diagram, so the message has to be safely transmitted from the sender to the receiver via an unsecured channel. So, the message is transformed with the help of a secret information into a secured message, and the secured message is being transmitted via the channel, and when it reaches the destination site, the secured image is going to be further transformed and with the help of a secret information, and the recipient is getting the message which is being sent by the sender. Now, coming to the cryptographic system, so it is going to be characterized along three independent dimensions. The first one is the type of operation used for transforming the plain text to ciphertext. Examples for that, substitution techniques and the transpositioning techniques. The second dimension is the number of keys that is being used. And here comes the symmetric encryption technique, which is a single key encryption technique, and the other one is asymmetric technique, where two keys are going to be used, which is otherwise called as public key crypto system. The third dimension is the way in which the plain text is being processed. Based on this, it is classified as block cipher, and another one is going to be the stream cipher. Now, coming to the second dimension, that is the number of keys that are being used, here we are going to discuss about the two encryption mechanisms. One is going to be the symmetric encryption and another one is going to be the asymmetric encryption. Now coming to symmetric encryption, it is also referred as conventional encryption and otherwise called a single encryption system. Here only one key is being used, and this is the method which is widely used by the people. And the basic terminologies that are being used in this encryption system is, first one is the plain text, which is actually called as the original message, and the ciphertext, which is the encoded message. And the algorithm that is used to convert the plain text into the ciphertext is actually called as enciphering. So enciphering or encryption, it is the process of converting the plain text into the ciphertext. And in the destination side, you have to get the message from the encrypted message, and the techniques that is being used is called as the decryption. Okay, and it is actually restoring the plain text from the ciphertext. Now, what is actually cryptography? Cryptography is the study of encryption. Next, what is cryptanalysis? The techniques that are used for deciphering a message without any knowledge of the encryption detail. And now coming to cryptology, which is a combination of cryptography and cryptanalysis. Now we'll look into a simplified model for symmetric encryption technique. As I told already, symmetric encryption is one where we are going to make use of a single key for the encryption as well as for the decryption process. Now if you look into this diagram, so we are having the plain text, which is actually here designated as S. This plain text is being converted into a ciphertext, and the algorithm which is given in this diagram is the AS algorithm, which is Advanced Encryption Standard, and the key which is used here is called as the key, which is denoted as K. So now the plain text X is converted into a ciphertext which is given as Y, that is, it is given Y is equal to encryption of the plain text X using the key K. And this encrypted message is being transmitted via the unsecured channel, and when it is reaching the destination site from the ciphertext, now you have to get what is the plain text. So the same key which is used by the sender is again used by the receiver for deciphering, and the algorithm is converting the ciphertext into the plain text. Now, so the ciphertext, that is this method is also called as private key cryptography, and here the same key is being used by the sender and the receiver. The name symmetric key is given because here both the parties, the sender and the receiver, both are going to be treated equally since they are sharing the same key. The next method used for encryption is called as the public key cryptography, and here when we compare this with the other method, that is the symmetric key encryption, two keys are being used, and the two keys are actually called as public key and the private key. And here, so here the private key is given more privilege than the public key, and the method is otherwise called as asymmetric method because both the parties are not going to be equal. Okay, so here the person who is having the private key is going to be given more privilege than the person who is going to use the public key. So here in this public key and the private key combination, so anyone can be used for encryption and the other can be used for the decryption. Now, what is the necessity for public key cryptography? and it is used to address two key issues. One is known as key distribution, which is how to have secure communication in general without having to trust a key distribution center with your key. And the second one being digital signature, that is how to verify a message comes intact from a client center. Now coming to the public key cryptography, and here the two keys are going to be used are, one is the public key, which is which will be known to more number of people, and the other one is going to be the private key. And here it is, the point to be noted is that the public key and the private key, it is going to be a pair of keys. And now if you look into the diagram, the public key crypto system, so here you are having the message. The message is actually here called as X, and you are going to make use of the encryption algorithm. For example, if you take RSA algorithm, it can be used for encryption, and here a key pair is going to be used. One is the private key and another one is going to be the public key. And here in this case, the private key is used for encryption, and the encrypted message is actually called as Y. And next, here the encrypted message is further encrypted with the help of the public key, and it is going to be transmitted via the communication channel, and it is reaching the destination side. And coming to the destination side, the private key of the receiver is being used to decrypt the message, and in turn later the public key of the sender is being used once again to decrypt the message to get the plain text, which is called as X. Now where this public key crypto system is being applicable, so it is used in three cases. One is for encryption and decryption of the message, which is in turn going to provide secrecy. Second one is going to be digital signature, which is providing authentication, and the third one is meant for key exchange, here for exchanging the session key between the sender and the receiver. Now to come into the examples for public key crypto system, there are three methods which are being listed out here. One is known as the RSA algorithm, second one being the elliptic curve cryptography, and third one is the Diffie-Hellman algorithm. Thank you.